तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Good day. Air, water and food are very essential for the human existence. These material which are so important for human existence, if they are polluted, they can create problems. For example, if air is polluted, there will be respiratory diseases. If the water is contaminated, it can cause waterborne diseases. If food is contaminated, then it could cause food poisoning. These three components which are so essential for human existence can also become scourge, can also become harmful for the human life. That is why it is very essential for us to see that these are not polluted. In fact, I would like to start the course on wastewater engineering with a proverb which says that, which goes like this: many lived without love, but none without water. The water is so much essential for our existence. So, this particular thing I invite you, with this I invite you to the video courses in environmental engineering. But this particular course we concentrate on wastewater engineering. Let us see the objectives of environmental engineering in general. I would like to state the objectives. The objectives of environmental engineering is to supply water which is safe in quality and also adequate in quantity. Two things are important here: the quality as well as quantity. The quality is important. If the water quality is not good, if water is polluted, if water contains harmful bacteria, then waterborne diseases will be there. The diseases like typhoid, cholera will be there. So, with this particular thing, what would happen is that the productivity of the nation will decrease. Secondly, if I do not supply water adequate in quantity, Government of India has suggested that we need to supply about 135 liters per capita per day. Per head 135 liters of water is required. So, if this water is not this water is supplied to keep the personal hygiene and to meet all water demands. If we do not supply this amount of water, then what would happen is that people would like to get the water from the sources which may not be safe. So, that is a big problem. So, quality and quantity are both important. Secondly, second objective of this particular environmental engineering is to collect, treat and dispose of the wastewater generated by the people in the community. So, we have to dispose of the wastewater in a environmentally friendly manner. In fact, 60% of pollution that is caused in India may be due to the domestic wastewater. Now, we have to have development. In order to have the development, we have got many industries. These industries produce pollutants of gaseous in nature, gaseous pollutants. They produce liquid waste, they also produce a solid waste which may be hazardous. So, all these pollutants like gaseous waste, liquid waste and solid waste ought to be treated before they are discharged into the environment. This is the responsibility of the industry, and government has a responsibility to see that the industries do treat the waste, treat their waste properly. So, as environmental engineering is a field which deals with the methodology of preventing the waste creation in the industries and also to treat the waste if it is generated. Always prevention is better than cure, that is what we try to see. The fourth objective of environmental engineering is about the air pollution. See, we have to keep the good air quality so that the respiratory diseases, pulmonary TB, etc. are not transmitted through air. So, we have to keep up the indoor air quality, we have to keep up the work environment air quality, we have to keep up the air quality in the industries. So, we deal with the air pollution from these sectors. Finally, environmental engineering also deals with collect, transport and dispose of the solid waste generated by the community as well as the industries. So, this is very important. We look around any city in India, we have so much of solid waste to be treated with. And there are several courses which deal with each aspect of this. In this particular course, we are going to deal with the two aspects, first two aspects. This course addresses the water and wastewater treatment. Now, I would like to say I have taken two attributes, that is the quantity and quality of water. So, the quantity of water people have realized in the earlier days itself the need for the quantity of water. If you see the human settlements, the human race has settled along the river banks, and these human settlements have become a great civilizations. For example, Indus Valley civilization has developed on the Indus River, and Ganga River is supposed to be the cradle for Indian civilization, and we have great Indian civilization because of the Ganges River, and we have got similarly other Greek civilization, so on so forth. So, all civilizations are developed on the banks of the river, and I would like to state that the people realized the importance of quantity much earlier. However, the quality of water aspect was rather slowly realized. It was not realized very at a faster pace than like quantity. So, the quality was, in fact, there are no recorded incidences of quality aspects. However, in Indian literature, Indian scriptures, if you see, the water was kept in copper vessels, okay, and copper vessels keep the quality very well. In fact, copper dissolves in water, and imparting a bactericidal property to water, the bacteria would be killed if water is kept in copper vessels. So, that was there in our scriptures. However, recorded incidences were not there. Recorded incidences like in the western world was there only in 1845 or so, 1854 rather, is the first recorded history about the quality of water. In this, what happened, in central London there was a health worker by name John Snow. Dr. John Snow was the name of the public health worker. He was the first person to correlate the disease spreading of the disease with the quality consumption of water. He said that if people consumed the contaminated water, there was a disease. So, there was also a he dealt with one hand pump in the Broad Street. It is called a Broad Street hand pump. In the neighborhood of this Broad Street hand pump, the cholera disease was rampant around this period, and the water got contaminated. The water table was shallow and water got contaminated, and people consuming this water had the disease. So then what happened was, he was the first person to correlate these two things, consumption of water with the disease. At that time, interestingly, germ theory was not known. We were not knowing that microorganisms cause the disease. It was only in 1900 it was established that cholera is caused by an organism called Vibrio coma, which is a bacterium. So that was established only in 1900, and much before that he was able to establish the relationship between drinking the water and the disease production. And then what happened? He wanted to see that the people do not drink the water from that hand pump. For that, what he did was, he removed the handle of the hand pump so that people could not take the water. Of course, for doing that offense he was punished, so without knowing the actual real reason by the authorities. Anyway, these are the two aspects, quantity and quality, most important, and history of quantity and quality is like this. And still I would like to say that this quality is remaining a challenge to the environmental engineers, to environmental scientists even today. With the invention of modern equipment, most sophisticated equipment like AAS, HPLC and so on, we are able to detect trace concentrations, concentration of pollutants in nano concentrations, nanograms, micrograms and milligrams. Very, very low concentration can be detected. For example, pesticide, maybe 20 years back or 15 years back we were unable to detect in water, but now yes, we can detect the presence of pesticides in water. So this particular thing, the quality aspect is going to be a challenging task for the engineers and scientists in future also, because as we keep on improving our equipments, we are going to detect more and more pollutants and more new pollutants which we were unable to detect in the earlier days, even though they were present. So that is what is importance of this quantity and quality. Now if you want to see the attributes of drinking water, attributes are some qualities of water, whether the water conforms to the particular standards. So first of all, there are three attributes I can say before I go to the standards. One is the aesthetics, second is the safety, third is the economics. So there are three attributes. I would like to write here aesthetics, safety and economics. So any water you produce should be able to meet these three attributes, qualities. Aesthetics is our physical perception. The water which we drink or water which we supply to the people should be colorless, tasteless, odorless and pleasing. These are the basic qualities of water. If water contains some turbid particles, suspended particles, people refuse to drink that water. If water contains some color, yes, we do not want to drink that water, okay. So that is aesthetic, and this is physical perception like our eyes, nose, tongue or instruments to detect these things, physical perception. And since it is a physical perception, subject is it is a subjective test, it varies from person to person, okay. Consumer himself is an instrument for this particular to measure the aesthetics of water. Second thing is the safety. Consumer is not the instrument, safety is the instrument. Probably is that we have to use analytical instruments, equipments have to be used. Safety from the microorganisms, disease producing organisms, I want to have safety from this. I also want to have safety from the toxic chemicals. So the safety is from two things. One is the microorganisms. So these microorganisms can cause microbes can be called as a pathogens, the one which produce a disease. The diseases are like typhoid, cholera, dysentery. Dysentery can be caused by bacterial cells as well as the amoeba. Entamoeba histolytica can also cause the amoebic dysentery, and infectious hepatitis, so on. These are some of the diseases caused by the microorganisms. Some of them are bacteria, some of them are protozoa, some of them are viruses. All those things are clubbed under this. So, as far as the toxic chemicals are concerned, I would not like to have water should not have toxic chemicals like heavy metals. No heavy metals should be present in water. Unfortunately, due to the anthropogenic activity, that is a man-made activities, some of the heavy metals are present in water, and nature also contributes some of the heavy metals to water. Example of nature's contribution towards heavy metal is arsenic in water. Arsenic is present in water because of the geological formation, and this arsenic is present in the West Bengal, groundwaters of West Bengal, and also in Bangladesh. That was the arsenic is present as a heavy metal in water. Similarly, the mercury poisoning, mercury is present in water. In fact, the fish, most of the fish have got mercury in them. Through food also we are getting the mercury, that is a heavy metal. Mercury, cadmium, nickel, zinc, so on. These are some of the heavy metals which should not be present in water, and they are all coming due to the anthropogenic activities, the activities of man. And this, the another naturally occurring pollutant is a fluoride, F minus, fluoride. Fluoride also should not be present in water, and it is, there is a limit for fluoride. If it is excess than that is required, then present, it causes dental fluorosis, or it causes what is skeletal fluorosis. Dental and skeletal fluorosis is caused by the presence of fluoride in water beyond certain limit. If dental fluorosis is there, then what would happen is it would discolorize the teeth. Teeth will be ugly, okay, particularly for ladies and girls, this is a problem. Second thing is that that is a cosmetic effect. Second thing is skeletal fluorosis, the bones become weak, they develop a stoop, okay, so on and so forth. So, if water contains the nitrates, in above permissible limits, then it causes what is called a blue baby syndrome. That is all we study in the books, blue baby syndrome. So, these chemicals should not be present in water. So, the consumer cannot know that whether these chemicals are present or not, because he cannot see them. So, you have to depend on the equipment. As far as the public health authorities are concerned, like we have to make sure that the water does not contain these chemicals, no harmful chemical should be present. Third aspect is water should be produced economically. There is no point in producing water which is very expensive, okay. You have to have a very reasonable cost of production of water if you want to supply to the people. So, these are the three important attributes. The next thing, let us see, as a result of all these things we are producing potable and palatable water. Next part, if you see how much quantity of water is available to us for supplying to the public, for industrial use, for agricultural use, for recreational use, if you want to see that particular thing. Water that is available for us can be divided into different categories. The groundwater, number 1 is the groundwater, number 2 is surface water, number 3 is the lake water, number 4 is the sea water, number 5 is the treated effluent. These are the 5 categories I have divided, and we see first of all, out of no, 3/4 of Earth's surface is filled with water. Most of the water is locked up in the ice caps and glaciers, and only 0.62% of water is available as fresh water, which can be used for the supply purposes. So, we have very little water that is available. So, 0.62% of the total water available, 0.62% of total water is available for as fresh water for supplies, and these waters are available, these are waters are present as the groundwater. So, let us take the groundwater first. Groundwater the aquifers under the ground bear the water. This is a water bearing aquifers are present under the underground. So, this water, if you are drawing from the aquifers which are less than 30 meters deep, that is they are called shallow wells. Shallow wells draw the water from the aquifers which are less than or equal to 30 meters. And these shallow wells, there could be shallow tube well, this is a dug well, maybe you have got water in 10 meters. Some places in the northern zone in the Gangetic plain, you get water just you go by 4 to 5 meters you get water. Okay. Those water are all shallow wells, shallow tube wells we have, and there is a problem with this water. These problems, these waters are prone for bacteriological contamination. The bacteria may be present in this water, pathogenic bacteria may be present. So, the shallow well waters may have a problem of bacterial contamination. This water contamination, I will write it here, they are prone for bacterial contamination. This water may be free of turbidity, there is no turbidity present, but they have bacteria, they can cause disease. So, we have to be very careful about those shallow wells. Now, if I want to draw water from a deep source, we have a deep tube well whose depth is around 300 meters. That means, I can draw water from a well which is 300 meters deep. This, if I draw the water from 300 meters deep, it is called a deep tube well. So, this water definitely does not have bacteria. So, in the deep tube wells, I do not have bacteria. Deep tube wells, no pathogenic bacteria. Why there are no pathogenic bacteria? The pathogenic bacteria are filtered when the pollution is entering into the river, they are all filtered, that is what no bacteria may be present. However, the water may contain some inorganic presence of inorganic pollutants, inorganic toxicants, I will put it here, toxicants may be of concern to us. This is a concern. This is happy news, no pathogens, but it may contain some of the inorganic contaminants or inorganic toxicants. Example, deep tube wells may have the fluorides, deep tube wells may have arsenic. So, we are solving one problem, but getting another problem, that is what it is going to be. And also the groundwaters are generally have iron and manganese, that is what I have written here. Iron and manganese is also present in the groundwater. Iron is going to cause color to the a color problem. The water may get colored if iron is present. Okay, it does not cause, I mean iron and manganese beyond a certain limit may cause stomach disorders. Stomach disorders are also caused, but that is not very important. Most important thing is that my clothes get stained, the laundry is affected, okay, because of the presence of iron and manganese. Now, let us go to the surface water. At this time, as introduction, I would like to state these things. Let us go to the surface water. Surface waters are probably most polluted waters available, okay, polluted water resources available. So, we have in the surface water may be receiving the untreated effluents from the domestic sector, untreated effluents from the industrial sector, untreated effluents from the any other source, agricultural sector, they may be receiving the waste waters. When the waste waters are received from the domestic, industrial, agricultural sectors, then the water is highly contaminated. So, if you are taking this particular water, basically we have to deal with the problems like pathogens, we have to deal with the problems like organic and inorganic pollutants. So, we have lot more problems with surface waters. Basically, surface waters do have turbidity. Turbidity is also present in the surface waters. Besides turbidity, we have got the pathogens and organic and inorganic pollutants. So, now let us go to the next thing, the lake waters. If you see the lake waters are present in the big reservoirs, and this lake waters have a natural sedimentation in the reservoirs. Since there is no turbulence in the lake waters, what would happen is that algal growth will be more. Since the algae grows, and then algae presence of algae itself produces some taste and odor problems to water. So, if you are taking water from the lake, it would have some organics which cause taste and odor, and these taste and odor problems have to be dealt with in our treatment. Okay, the cost of the treatment will increase because we have to deal with the taste and odor. However, the water will not have the will have very less amount of turbidity. Now, let us go to the sea water. Next, sea water is plenty available plenty. However, the sea water suffers, if you want to use the sea water for the domestic use or for industrial use, you have to remove the salinity first, and also you have to remove the total dissolved solids. So, in order to make this sea water as a potable water, we have to use desalination. Okay, desalination plants are there. In fact, in Middle East, we have many desalination plants. Okay, they remove the solids from the sea water and use that particular water. They use reverse osmosis, that is a technique that is used for making the sea water into fresh water. And in fact, we have this in Tamil Nadu and some other parts. We have to use the sea water for making a potable water. I have an example in Gujarat, in Bhavnagar, we have a desalination plant which will convert the sea water into fresh water, and there are cases in Tamil Nadu also where the sea water is converted into fresh water. However, there are several problems. In order to produce potable water from sea water, we do require electricity, high energy. So, this energy has to come from solar energy. If you are able to trace the solar energy, then you can use the desalination very effectively. Okay. Then fifth one is the treated effluent. You may be surprised, how could I use treated effluent as a source of water? Yes, you can use treated effluent as a source of water. The treated effluent could be used for some purposes. Number one, I can treat the effluent, that is treat the wastewater and use it for gardening. I can use the water for the flushing. I can also use this water for the air conditioning. So, there are many industries which purchase the wastewater from the community, from the municipality and treat it. Okay. Maybe they even sometimes do the secondary treatment. The municipality has to do the secondary treatment. They do the tertiary treatment, third degree treatment, and use that water for air conditioning purposes. There are examples, that is Chennai Fertilizers or MRL, that is Madras Fertilizers Limited, uses this particular thing. Okay. And similarly, the Chennai Petrochemical Limited also uses the treated effluents for water. No, it is treated effluent for water for air conditioning. So, it is a high potential is there as far as the usage of treated water, treated effluents as water sources. In fact, this is also called as a zero discharge. That means, I am not allowing any effluent going out of my premises. Okay, that is what is called a zero discharge. So, next slide, let us see that the quantity of after seeing the quality, we will go to the quality. Quality of raw water depends upon the source of water and also the point of intake, where from I am taking this particular water, and also source. Here I would like to take the example of Ganga River, because that is very important river, and we have what is called a Ganga Action Plan, which gave rise to National River Action Plan strategy in India. We want to keep all our rivers clean. So, Ganga River started as a spring in Himalayas at Gangotri, okay, and this spring traverses through the hills Himalayas and then comes to plain at a place called Haridwar, and from there it travels on the plain, it travels on the land interior of India. It traverses for 2525 kilometers before it enters into Ganga Sagar in West Bengal. It reaches the ocean there. So, all along this particular river, great cities have come up. The great cities which are religious in nature, religious importance, learning and scholarliness importance, and also industrial. So, for example, Haridwar is a great religious center, and Haridwar Ganges enters into the plains, and before it enters into the plains, the water is crystal clear, the water is very pure, excellent water we have. As soon as it comes to the Haridwar, and millions of people take bath in the Ganges river, and we have got melas, Kumbh melas, Ardha Kumbh melas, and solar eclipses, lunar eclipses. People dip themselves, want to purify themselves in Ganges river and transfer their sins to the Ganges river. Definitely, indeed, they are transferring the pollution at least. Okay. So, that is Haridwar. After Haridwar, the water goes to the river flows to Kanpur. Kanpur is a place where it has got several industries, several different types of industries, I would like to say. There are textiles. In fact, Kanpur was known as Manchester of India. Textile industries, paper industries, tanneries, and also allied chemical industries, several industries. All the industries use the water, and especially the tanneries. Some of the tanneries, there are more than 100, nearly 200 tanneries. These tanneries use the water and produce the wastewater and dump into the river. I mean, this was happening earlier, at least not now. Okay. So, this water with highly putrefied effluent was going into the river Ganges and depleting oxygen from the Ganges river, and as a result of which there used to be fish kills, there used to be bad smell, and unsightly river used to be there, as far as the Kanpur is concerned. Then after Kanpur, we have Allahabad and Varanasi. Allahabad and Varanasi, as you know, is a very great pilgrim centers. Particularly Allahabad, 3 rivers meet, that is Sangam, Ganga, Yamuna, Saraswati. 3 rivers meet, okay, and Saraswati is a hidden river. And at that Sangam, people take bath, millions of people take bath during the Kumbh melas, Ardha Kumbh melas, and solar eclipse, and all types of eclipses they take bath, and then pour lot of ghee, sugar, milk and flowers into the river. Okay, they offer as a part of the prayer. So, because of this, Ganges is highly polluted, gets polluted. Then at Banaras, besides this puja samagri going into the river, there are even dead bodies, that is half burnt dead bodies are being thrown into the river with an idea that the dead soul will get the salvation. So, that is a belief, okay, we can't help it. So, because of all these things, there is a plenty of pollution in the Ganges river, and the river flows to Patna. Patna has got the domestic and industrial wastewater dumped into it. This is a trace of river Ganges starting from Himalayas and traveling through India, the several states of India, about 2525 kilometers, and reaching the Bay of Bengal. And here you can see here, this is a blue color, this is a pretty good water, this is somewhere Haridwar, and at Haridwar the water quality is pretty good. Afterwards it comes to Kanpur, Kanpur water quality is bad, and then you can see here after this the river revives to some extent, and from Allahabad again the Allahabad also, the Allahabad to Varanasi, the water is little better than what is there at Kanpur, because Kanpur has industrial pollution, and then afterwards it reaches Patna, and from Patna again the color is changed, so to the bad quality water. So, in fact, the river reaches the Bangladesh as Padma river, and a part of the river reaches the Ganga Sagar. So, by this slide I want to explain one more point. If you want to take water for supply, if you want to take this as a raw water for supply from say for example from here for the Haridwar, we have very good water, raw water quality is pretty good, and hence the treatment that should be given will be less, and the cost of treatment also will be less. As you pick up the water, heavily polluted water, then the pollution is more, and hence the cost of the treatment has to be more extensive, and maybe the cost of treatment will be more. So, all along the river this particular thing, these cities like Kanpur, Allahabad, Varanasi, Patna, etc., the treatment has to be more extensive than that it can be given at Varanasi. So, these are the some of the aspects we would like to say on the quality when you look at the river. So, in fact, Government of India has instituted a program called Ganga Action Plan. What they want to do is that, especially at Kanpur, they want to divert all the wastewater, untreated wastewater going into the river. They want to divert it, intercept it and divert it, and then bring it to a treatment plant, treat the wastewater, and then again put back the treated effluent in the Ganges river. So, this is what is called under Ganga Action Plan they were doing it. Now, National River Action Plan has come, wherein every river has this plan by means of which they are trying to treat the wastewater, untreated wastewater going into the river is being intercepted, diverted, treated, and then discharged into the river. So, this is the progressive thing what is being done now. Now, if you take this how exactly this pollution is happening, and what is the the capacity of the environment to take up the pollution, then we will move to what is called pollution level. I want to introduce another term what is called pollution level, and also introduce another term what is called carrying capacity. All rivers, for that matter environment in general, has got what is called carrying capacity. Carrying capacity is nothing but the environment can assimilate the pollution dumped onto it. It can assimilate and it can take care of the pollution put onto it. If the pollution were to be natural pollution, if the pollution is biodegradable pollution, then the nature can take care of it very easily. If the pollution is not natural, if pollution is man-made, that is what is called anthropogenic pollution. Pollutants are anthropogenic. One simple example I can give of anthropogenic pollutant is plastic cars which we use. This plastic, right, can stay in the environment for years together, for a long time. Even my great grandson can also see the plastic cover which I have used. They are non-biodegradable organic matter. Now, of course, we are trying to manufacture biodegradable plastics. So, what I am trying to say that the environment has got what is called a carrying capacity, and this carrying capacity is restricted to only natural pollutants, not to the anthropogenic pollutants. For example, pesticides are there, pesticides are man made thing, and environment does not have answer for it. Okay. These pollutants keep on accumulating in the environment, and hence they are called as conservative pollutants. Conservative pollutants means they will not get destroyed. Okay. So, the carrying capacity is not there for those pollutants, while for biodegradable things the environment has got what is carrying capacity. Rivers have got self cleansing capacity or self purification capacity, that is what is called carrying capacity of the river. Earlier, when there was not much of industrialization in India, and also the not much of green revolution in India, then what was happening is that the pollution level is less than the carrying capacity of the environment. In this case, let us take the river, self purification capacity of the river. So, it used to be the carrying capacity is always greater than the pollution level, and there was not much effect of pollution prior to this particular thing. However, we want to have industrialization. Definitely industrialization is required, we have to progress, and we have to have green revolution. Is because of that we have got surplus food today. Green revolution is a must, and in green revolution what we have used is we have got plenty of fertilizers, different types of fertilizers. We have used different types of pesticides, insecticides, so that we can avoid the competition from these insects and pests. That is why we have used insecticides. So, the green revolution has brought in the pesticides and insecticides and fertilizers into the arena of our chemicals, and population explosion is there, high population growth is there in the country. Because of this, domestic wastewater has increased, and we have modernization. We would like to have air conditioning, we would like to have automobiles, we have got carbon monoxide, carbon dioxide, NOx, SOx, oxides of nitrogen, oxides of sulfur, hydrocarbons in the atmosphere. Okay. All those things are there because of intense modernization with respect to automobile industry, and also we have the CFCs, okay, for the air conditioning. So, because of this particular thing, we have many pollutants being introduced into the environment, and environment does not have answer to these new anthropogenic pollutants, and as a result of which the pollution level is greater than the carrying capacity of environment. So, when pollution level is more than the carrying capacity, the problems have started. We have the problems. The problem is that we have skies laden with smoke, rivers having fish kills, no oxygen, depleted oxygen in that particular thing, and everywhere the solid waste around in the towns and in cities. This is the scenario now. So, I am not suggesting that we should not have sustainable development, we should have sustainable development. Sustainable development is we have to develop with a concern for the environment. We should not destroy the environment during the process of development. So, at this moment of time there is a role for the environmental engineer. So, intervention by the environmental engineer is needed at this time to change this inequality. Inequality is, that is, pollution level now should be less than carrying capacity. That is what I want to do it, okay, as environmental engineer. So, what does environmental engineer do is, environmental engineers, what they do is they engineer the processes that are present in the nature, that is processes like self purification, and they study those processes and increase the rate of reactions of those processes and make these processes to occur in a limited space or limited volume called a treatment plant. That is what he does. So, a reaction which is taking place in the river in 100 days. Now, the environmental engineer can do the same reaction, can perform the same reaction, can allow the same reaction to take in 10 days time or in 10 hours time, okay, or in 10 minutes time. So, that is his capability now. That means, he is able to amplify the reaction rates such a way that the reaction takes place in a limited amount of time, okay, within a short span of time. Nature also does the same thing, but it does with a lot of time, maybe 100 days it takes. So, that is what it does. He does that particular thing. He is trying to do only that particular thing that he learns from the nature. Now, let us take that I have introduced a treatment. Treatment is required. Treatment is done by the environmental engineer. And now, you may ask me, what is the extent of treatment to be done? Extent of treatment, if I take the water treatment, extent of treatment to be given depends upon the water quality and beneficial use of water. And the water quality depends upon at what point you are taking. Am I taking water from Haridwar? Am I taking water from Kanpur? Am I taking water from Banaras or Varanasi? It all depends. Quality depends on the place at which I am taking the water. And beneficial uses are the following. One is the domestic use, industrial use, recreational use and agricultural use. In the domestic use, if I want to supply water to the domestic, it has to be high quality. Quality of water should be very, very high. That means, safety is most important thing for me. I want no pathogen to be present in water. I want no heavy metal to be present in water if I want to supply the water to the people. And from the consumer point also, I should satisfy the water quality, that is, water should be pleasing, water should not have taste, water should not have color, water should not have suspended particles. So, high quality water. And in industry, water is required for various purposes. One purpose is process water. Process water is use of water in the process, in the production of a produce. So, for example is the steam water. Steam generation, I want to generate the steam. Steam is generated by using the water, and that water should have no hardness, you should not have no minerals, and hence I should have a treatment called demineralization. I should remove all minerals from water from the boiler feed purposes. Now, second is the production water. Production water is water becomes an integral part of the produce. Example, if I take the food processing industry, beverages or soft drinks, the quality of water that is used in manufacturing the soft drink should conform to the standards of drinking water. You should not have pathogens, you should not have pesticides, you should not have any toxic chemicals. That is what it is. If I am producing textiles, I should not have iron, I should not have any components present in water which cause color to the textiles. Similarly, if I am producing paper, this should not cause any color to the paper, because I want to produce excellent paper, I want to produce excellent textile, not colored textiles, so on and so forth. Then third water is the transport water. Water is used for the transporting the material within the industry, maybe lumber industry, okay, timbers, etc. They are all floated, they are all transported through water. Second, another thing is housekeeping. Housekeeping purposes, we could have a low quality water. I do not have to have the production water or process water quality. And another important use of water is the cooling water. Cooling water is a water which picks up the heat from the equipment, okay, from the heat exchanger, so on and so forth, and the temperature of the cooling water increases. So, the temperature is a pollutant there. That water quality should also can be low. Next, we have got the recreational water, water that is used in the swimming pools. This water should have a quality of not having any organisms which cause due to water contact. They should not produce water contact diseases. For example, the swimmer's itch is caused by a fungus, so water should not contain fungus. Also, another disease which is normally transmitted through swimming pools is the conjunctivitis, that is red eyes, that should not be present. Third thing is that water should not have excess chlorine. If swimming pool water has excess chlorine, it will cause irritation to the eyes and mucous membranes. The fourth quality water beneficial use is agricultural water. This agricultural water is a large quantity of water is used for agricultural purposes. The water quality for agricultural is of importance. For example, the water should not have high TDS, it should not have high sodium content, and should not have high SRA, sodium absorption ratio. If these quantities, these parameters are higher than the required quantities, then what would happen is that they will have certain problems. Number one problem is the plant will not get enough calcium. Calcium does not enter into the plants. Second thing is that the sodium will form salinity to the soil. Salinity of the soil will increase, and as a result of which the soil becomes non-fertile. Fertility of the soil will decrease. The third thing is SAR, sodium absorption ratio. If the sodium, these things are high, what would happen is that all things together, I would not like to separate out, the soil becomes impervious. When soil becomes impervious, oxygen transfer from atmosphere will not take place to the root zone, it will not go down. At that time we have to disturb this soil, okay, impervious soil. So that is called tilling. You have to do tilling. When you do tilling, the cost of agriculture is going to increase. So that is what is the beneficial uses, and that dictates the quality of water. Next, in order to do this quality enhancement, we require treatment plants. The treatment plants, or several treatment plants are there. In this I want to say that water is a continuum. It is a very important thing. There is a continuous phase. For example, the wastewater discharged at Haridwar becomes a water at Kanpur. The wastewater discharged at Kanpur becomes water at Allahabad, and so on and so forth. That means it is a continuous phase. So in other words, water is a continuum. There is no difference between water and wastewater except in quality, and wastewater is nothing but 99.99% water and remaining solids, but these solids are biodegradable solids. That is what we said. So the difference is in biodegradable organic matter. So what I would like to say that whatever treatment technologies I employ for treating the water, same technologies could be applied with modification to wastewater treatment. Principles, basic physical, chemical, biological principles being the same, only thing is the modifications are required. However, for treating the wastewater, I require additional treatment units because I want to remove the biodegradable organic matter. So the selection of treatment now depends upon the nature of pollutants. Okay, depending on the nature of the pollutants, we have the selection of treatment processes, treatment technologies. So if we see the nature of pollutants can be divided into three type of categories. One is the pollutants in the molecular form, pollutants in the colloidal form, pollutants in the coarse form. All these three categories is based on the size of the particles. For example, if the size of the particle is 1 nanometer or less, nanometer is 10 to the power of minus 9 meters. If it is less than that particular thing, then it is called a molecular form. For example, calcium, magnesium, sodium are in the molecular form. The colloidal form could be divided into two categories again. One is called ultra microscopic, where the size is about 500 nanometers. Okay, size is very less. So you can see only with the ultra microscope like electron microscope. Another one is the microscopic. Microscopic can be seen with the help of a microscope. Coarse one is the bigger particles. The size is about 20 micrometers. So in order to remove these pollutants, we do require a treatment systems. We require a treatment system, and in order to have a treatment system, we have designed treatment plants. These treatment plants have got the design periods, and most of the times the design period of a treatment plant is 15 to 30 years. That means I design a treatment plant now, you should be able to serve the population at this time and also should serve a population 30 years from today. That is what should be the design treatment plant. In order to do that, we need to go for population projection methods, because I should know the population after 30 years. In order to know that, we have got the methods for population projection, and this will be taken in the next class.